Welcome students. Again we are starting with one important concept and then we are going to discuss the questions asked in the previous year Neet examinations. Okay, today's concept is the energy level diagram for an atom, hydrogen energy level diagram we study in the chapter atom. Okay, this is based on the Bohr's atom model. Okay, this is the nucleus of an atom. It contains Z protons. Atomic number is Z. This is one circular orbit, the nth orbit, Rn is the radius, in which there is an electron which is revolving around this path. Okay, now what is the energy of this electron? Electron has got potential energy and also it has got kinetic energy. Okay, you recall this concept you studied in electrostatics. There are two charges Q1, Q2 separated by a distance r. It has got potential energy. Epsilon is given by 1 by 4 pi epsilon naught Q1 Q2 by R. You know this concept. Okay, making use of that concept here, the potential energy of the electron is 1 by 4 pi epsilon naught product of the charges divided by the distance between the charges. Okay, this is the potential energy. So what is the kinetic energy? The velocity of the electron in the nth orbit is Vn. So the kinetic energy is half m Vn square. So this is the kinetic energy. So what is Vn? Let us find out using this concept. Centripetal force is equal to electrostatic force. When the electron is going around in the circular orbit, the condition which satisfies is the centripetal force is equal to electrostatic force. What is the formula for centripetal force? It is mv square by r. This is Vn Rn because it is in the nth orbit. And what is the electrostatic force between the charges? Is 1 by 4 pi epsilon naught product of the charges divided by distance square. We will not put minus E here because the magnitude of the electrostatic force is equated to the centripetal force. Because phi will not be equal to minus phi. We don't put that minus sign here. Then now Rn square. This is cancelled. So you get what is Vn square. Vn square is 1 by 4 pi epsilon naught Ze square by mRn. This is Vn square. Okay, let us substitute this Vn square here in the kinetic energy. So kinetic energy is half m Vn square. So what is that? 1 by 4 pi epsilon naught Ze square by mRn. Now m and m gets cancelled. You get 1 by 8 pi epsilon naught Ze square by Rn. This is my equation number 2. This is kinetic energy. Now you look at these two formulas. One is potential energy. The other one is the kinetic energy. So now we are going to make the total. So the total energy of the electron in the nth orbit is nothing but the potential energy plus the kinetic energy. Let's find the total. Okay, come here. So the total energy is 1 by 4 pi epsilon naught minus is here Ze square by Rn. Potential energy plus kinetic energy 1 by 8 pi epsilon naught Ze square by Rn. If you observe here, what you observe here is if this is taken as x, okay, and this is actually how much? Multiply by 2, you get this, and put a minus sign, you get this. Therefore, do you understand that if this is x, kinetic energy is x, then the potential energy is actually minus 2x, and this total will be equal to minus x. What is this minus x? That is the total energy. So you should understand this one. Okay, next. Say, okay, what is the total? It is minus x. Okay, the total of this is minus 1 by 8 pi epsilon naught Z e square by Rn. Okay. Then another thing, the radius of the nth orbit, we study before this calculation, you would have studied this. Radius of the nth orbit is n square h square epsilon naught by pi m z e square. You should know this derivation of the radius. That we will try to discuss in a different video. Okay. Substitute that here. So, if you substitute this, the total energy, that I name it as En, okay, total energy is written as En. So this is minus Ez E square by 8 pi epsilon naught and reciprocal of the Rn, that is pi m Ez E square divided by n square h square epsilon naught. So you cancel this pi. So what do you get? Minus m Ez square e power 4 by 8 epsilon naught square n square h square. Okay, this is the important formula about that energy. Okay, so we have got a formula for energy in the nth orbit for any atom based on the Bohr's atom model. Okay, now what is it for hydrogen? Let us see. So now you take this Z square by n square. See here, what are all the variables and what are all the constants? This is a variable because atomic number is 1 for hydrogen, 2 for helium, 3 for lithium, like that it is a variable. And n, this is first energy level is 1, second energy level is 2. Therefore these two are variable. Then other things are permanent constants. The mass of electron is a constant, charge on electron is constant, epsilon naught is a constant, Planck's constant is a constant. Therefore all these constants, put the numerical value and simplify. Then convert to electron volts, you get minus 13.6 electron volt. Okay. Now what you got is the total energy is Z square by n square into minus 13.6 electron volt. Okay. Now for hydrogen, the Bohr's atom model is valid only for atoms which has only one electron. Say this, only one electron. When there is only one electron, we calculate the potential energy like this. Suppose if there is one more electron, the potential energy will be different. That is why the Bohr's atom model is valid only for hydrogen and it is valid for helium ionized, lithium doubly ionized, because these atoms should have only one electron, then only these formulas are valid. Okay. Now I am going to calculate the values for hydrogen and also for helium lithium. Okay. I put Z is equal to 1. So Zn is equal to minus 13.6 by n square electron volt. This is for hydrogen. Okay. I put n is equal to, I make a table. Okay. 1, 2, 3, 4, 5 like that. This is the principal quantum numbers. I put 1, 2, 3, 4, 5. That means for hydrogen, this is the first orbit is n is equal to 1, second orbit n is equal to 2, third orbit n is equal to 3, like that it goes. So what will be the kinetic energy, what will be the potential energy and what will be the total energy? Let us see. Okay, ready? Right. Now En is minus 13.6 by n square. So when n is equal to 1, E1 will be minus 13.6 by 1. Therefore, it will be minus 13.6. And you know, kinetic energy will be plus 13.6. Why? Because if it is kinetic energy is x, the total energy is minus x. This is minus 13.6. Therefore, this is 13.6. This will be minus 27.2. You have to multiply by 2. So this is minus 27.2. When you total kinetic plus potential, you will get the total. Okay, this is first level. Second level, you have to multiply by 2 square, 4. You get minus 3.4 electron volts. So the total energy minus 3.4, kinetic energy plus 3.4, potential energy minus 6.8. When you divide by 3, E3, minus 13.6 divided by 9, minus 1.51. This is minus 1.51, this is plus 1.51, this is minus 3.02. And you are going to the fourth level, minus 13.6 by 16. If you divide by 16, minus 0.85 electron volt. This is minus 0.85. This is plus 0.85. This is minus 1.70. And finally, let us come to the fifth level. Fifth level, minus 13.6 by 25, this will be minus 0.54. So this is minus 0.54, this is plus 0.54, this is minus 1.08. So you should remember all these values and you should know how it is calculated. Okay, supposing if the question is, what is the energy of the electron in the first orbit? Minus 13.6. What is the total energy of the electron in the second orbit? Minus 3.4. This second orbit itself can be called as first excited state. The electron normally it is here. The atom is in the ground state. When the electron goes to this level, when energy is incident on this, the electrons get shifted to the next level. Now the atom is called, it is in the excited level. So this is the first excited state. So when hydrogen is the first excited state, what is the energy? That means it is N is equal to 2, energy is minus 3.4. Supposing if the question is, when the hydrogen electron is in the second excited state, okay, N is equal to 3, second excited state, what is the kinetic energy? That means you have to come here, kinetic energy 1.51. If the question is what is the potential energy, you have to say minus 3.02 electron volts, like that. Okay, ready. Now let us calculate for helium, lithium. Okay, right, come. So energy is minus 13.6 into Z square by N square. For helium, it's ionized. So N is equal to 1, 2. So here, what is the kinetic energy? What is the potential energy? What is the total energy? We are going to see. Okay, now for helium, you will put Z is equal to 2. Therefore, the formula will become minus 13.6 into 4 by N square. Okay, I put N is equal to 1. Therefore, what I get, minus 13.6 into 4. That is minus 54.4 electron volt. Kinetic energy plus 54.4. And what is the potential energy? It will be minus 108.8. Okay. You have to multiply by 2. Okay. Now, second level you come. Second level means N is equal to 2. So here will become 4. 4 and 4 will get cancelled. Therefore, this is minus 13.6. This is plus 13.6. And here you will have minus 27.2. Like that you have to calculate. And if you go to lithium plus plus, what will happen? The energy formula will be minus 13.6. This is Z is 3. So 9 divided by N square. So here, when N is equal to 1, 2, what is kinetic energy? What is potential energy? What is the total energy? You have to make the calculations. Okay. So now, when I put N is equal to 1, I get the total energy. So that is 54, 4, 5, 27, 5, 32, 2, 3, 9, 12, 122.4. Minus here 122.4, that is plus. Here's 244.8, that is minus. Like that you have to calculate. Now you go to the second level. This is by 4. Okay, so you have to divide this minus 13.6 into 9 divided by 4. Divide by 4. So you get 30.6. So here plus 30.6. Here minus 61.2 electron volt. You understand this? So this is how the energy is calculated. Okay. After calculating the energy, we draw a diagram, and that diagram is the title of this discussion, energy level diagram. Okay. So you recall the numbers. Now I am going to draw a diagram that if I draw it properly, I have to take a scale and go 13.6 centimeters below. If 1 centimeter represents 1 electron volt, I have to go from reference line 13.6 centimeter below, and I will name it here minus 13.6 electron volt. This is N is equal to 1. Then I will mark in my scale 3 centimeter. Okay, maybe it is here. I'll say this is minus 3.4 electron volt. This is N is equal to 2. Then I will mark it somewhere here and say this is minus 1.51 electron volt. N is equal to 3. Now you watch the distance. This is this much. This is very near. Now the next energy level will be very, very near, and that is minus 0.85. So definitely the gap is less. N is equal to 4. The next one will be very, very close to this. How much is that? Minus 0.54. So naturally this is very small gap, and it comes like this. And this reference line what we have taken is energy level 0. When will the energy become 0? When n becomes infinity, isn't it? Because the energy is 13.6 by n square. When n becomes infinity, the denominator is infinity, the value will become 0. So when the electron is removed, that is the atom is ionized, then the energy will be 0. Okay, it is like this. Okay, supposing for example, in the hydrogen atom, if the electron jumps from first level to second level, why should it jump? We have to give energy. Only when we give energy from low energy level, it can go to high energy level. Why this is low energy level? This is minus 13.6. This is minus 3.4. Which is greater? This is greater. Minus 3.4 is a bigger number than minus 13.6. So, n is equal to 2 is a higher energy level compared to n is equal to 1. So, it has to go to high energy means somebody has to provide energy. Therefore, one photon is falling on this, then it jumps to this level. That is called, from n is equal to 1, it goes to n is equal to 2. This is called excitation. It may go directly to 3, that is also excitation. Here it goes to the first excited level, here it goes to the second excited level. So supposing if you want to find what is the energy of the photon, you have to find the difference. This is E1, this is E2. What is the energy of the photon? That is the difference energy, E2 minus E1. What is E2? Minus 3.4. This is minus minus. So the total is 10.2 electron volt. Understand? So from 1 to 2, the photon energy is 10.2 electron volt. Come here. From 1 to 2, if the electron has to go, the energy required is 10.2 electron volt. That is called the excitation energy. From 1, if it has to go to 3 directly, how much will be the energy required? So, E3 minus E1. Okay, that will be, E3 level is minus 1.51 plus 13.6. That will be 12.09. So, if 12.09 is the energy given, then it will go straight to the third level. And similarly, from here to the fourth level, how it will go? E4 minus E1. What is E4? Minus 0.85 minus 13 plus 13.6. The difference is 12.75 electron volt. So, if the photon is 12.75 electron volt, then it will go straight away to this place. Then we should know the behavior of the electron. Once electron goes to the higher level, from 1 to third level, 1 to third level, what it will do? It will not be comfortable here in the excited state. It will try to come down. It may come to second place. That is called transition 3 to 2. It may come from 3 to directly to the first level also. It is called transition 3 to 1. After coming to second place, then it might come from second to 1. So that is another transition. So these three types of transitions are possible. So if you excite the electron from first level to the third level, how many transitions are possible? So from 3 it can come to 2, from 3 it can come to 1. After coming to 2 it can come to 1, so 3 transitions are possible. Another question, among these 3 transitions, which is more energy? See, whenever the electron jumps from higher energy to lower energy level, energy is radiated, energy is released by the atom, energy is radiated. Which is having more energy? If that is the question, you have to see which is having more gap. That means, is it 3 to 2 or 3 to 1 or 2 to 1? It is actually 3 to 1. So you have to say this has more energy. Which will have more frequency. If the question is like that, more energy, E is equal to h nu. More energy means more frequency. And we can also write it like this. So more energy means less wavelength. Which is having less wavelength means you have to say 3 to 1. Which is having more wavelength? If that is the question, you should go to minimum energy. Where is minimum energy? It is 3 to 2, because the gap between 3 and 2 is very, very less, 1.51 to 3.4. That is the gap. Okay. So that is the minimum energy and maximum wavelength. So, okay, students, I have given you some idea about the energy level diagram, and this is what you should know. Maybe you can again see the video once or twice, and now we are going to the Neet problems. Okay. these many problems appeared in Neet examination. This is 32 years Neet physics. Now this is the chapter atom and nuclei we are discussing. In this I marked this in red color pen. So question number 3, 1, 3, 6 like that. Totally 21 problems asked from the small concept. So in physics we have to find important concepts and work out as many problems as possible in these concepts. These concepts are called frequently asked concepts. Okay, now based on the energy level diagram, this question 1. Look at this question. This is Neet 2019. The total energy of an electron in an atom in an orbit is minus 3.4. That means this is n is equal to 2. Its kinetic energy and potential energy. Total energy minus 3.4. Immediately you can say this is n is equal to 2. Kinetic energy means it is plus 3.4. Potential energy minus 6.8. You understand? Kinetic, potential and total. If you make this total, it should come. This is minus x plus x minus 2x. So this answer, kinetic energy 3.4, potential energy minus 6.8. This is in the option D. Now we are coming to question 3. This is in Orissa Neet 2019. Okay. So this question is slightly conceptual. You can just see this. The radius of the first permitted Bohr orbit of the electron in the hydrogen atom is 0.51. That means Bohr's radius of hydrogen. And the ground state is minus 13.6. All these things we know. If the electron in the hydrogen atom is replaced by muon minus, that has the same charge as electron, that means minus E, and the mass is 207 ME. Mass of the muon is 207 times mass of the electron. Then what will be the radius and what will be the energy? You understand the question? Okay. What is given here is, for hydrogen the radius is 0.53 angstrom. The energy level is minus 13.6 electron volt. If in the case of, if instead of electron you change it as muon, it has got more mass. The mass of it is 207 times mass of electron. If it is like that, the charge is same. Then what will be the radius and what will be the energy? That is the question. Okay. So radius we have discussed that formula. No, radius is n square h square epsilon naught by pi m z e square. Where do you find m? M in the denominator. M in the denominator. Therefore, the radii of the new atom, the radius will be mass is in the denominator. So divide by this 207 times m. You replace this m by 207 mass of the electron here. So 200 times it will be less. Okay. Now approximately you can say this is 0.5, 1 by 2, and this is 200, 1 by 200. 1 by 4 is 0.25 and divided by 100. That means this is angstrom. Angstrom means 10 power minus 10. So when this goes up 0.25, 10 power minus 12. So the answer is this for radius R1 dash. Okay. Now let us find out the energy and then compare the answer. The energy formula, minus m z square e power 4 by 8 epsilon naught square n square h square. You remember we discussed this just now. So mass is in the numerator here. Mass is in the numerator. So energy directly proportional to mass. Therefore, the mass is 207 times increased. Therefore, energy also will increase by 207 times. Okay. Just multiply this by 200. Okay. You take it as, this is electron volt. So I take it as roundly 200. Okay. Into 13.6 electron volt. Okay. So 200 into 13.6. Okay, let us multiply. This is 27.2 into 100 electron volt. I can say that 2.72 into 1000 electron volt, isn't it? So this is 2.72 kilo electron volt. There is a minus everywhere, so it is negative. So come to this answer. The energy should be minus 2.72 kilo electron volt. That is here. And the radius should be 2.5 into 10 power minus 13 meter. And that is here. Okay, you understand? So here what you understand here is these formulas are also important. This formula and this formula, they are also important to remember. You have to remember this, then only you will know whether m comes in the numerator or denominator, and you can tackle these problems. And this is something peculiar. Okay, All other questions are very simple. This is slightly difficult. Okay, now come to question number 6. In question number 6, what is asked? The ratio of the kinetic energy to total energy. Okay, I put EK. Okay, kinetic energy, total energy ratio. What is this? Kinetic energy 13.6, total energy minus 13.6. What is the ratio? It is 1:-1. This is 1, this is -1. That is in the option B. Very simple question. Now I turn the page and I check where is the other question. This is the next question. This is slightly difficult, but I'll tell you how to do it. Hydrogen atom in the ground state is excited by a monochromatic radiation of 975 angstrom. Then number of spectral lines will be okay. Now I tell you a shortcut method. Lambda 975 angstrom. Immediately you should know how much is the energy in electron volt. How do you convert this faster is 1 electron volt means it is 12,400 angstrom. You should remember this one. Okay, so whenever you want to convert this lambda to electron volt, you have to do energy is equal to 12,400 divided by 975 electron volt. Like that you should do. Divide 12,400 by lambda. You remember like that. Okay, if it is 1000, this will become 12.4. 975, it comes to 12.75 electron volt. When the incident energy is 12.75, where it will go, we have discussed this concept, isn't it? If it is 12.75 minus 13.6, you are giving a photon of 12.75. When you total, it become minus 0.85. You know, this is n is equal to 4. So n is equal to 1 minus 13.6, then minus 3.4, minus 1.51. Next is minus 0.85, n is equal to 4. So come to this question. How many spectral lines are possible? So electron should be in n is equal to 1. And because of this energy, it has gone to n is equal to 4. This is 2, this is 3, this is 4. How many transitions possible? It can fall from 4 to 3, 4 to 2, 4 to 1. And also after coming to 3, it can fall to 2, it can fall to 1. After coming to 1, it can fall here. So totally how many spectral lines are possible? There are 6. Okay, 4 to 3, 4 to 2, 4 to 1, 3 to 2, 3 to 1, then 2 to 1. So totally 6 spectral lines are possible. This is answer C. Okay, now I go to then the next question is question number 36. An electron in the hydrogen atom jumps from the excited state to the ground state. The wavelength so emitted illuminates a photosensitive material. Work function is 2.75. What is the stopping? The stopping potential is 10. Then what is the value of n? Okay. Now, in physics, sometimes they combine 2 chapters. Okay. Here, how is the combination? Is Einstein's photoelectric equation is combined with the energy level diagram. Okay. How much is the work function? 2.75. How much is the kinetic, based on the kinetic energy? So you know this can be written as E is equal to W plus EV naught. This is the stopping potential. So 2.75, 10 electron volt is the kinetic energy because the stopping potential is 10 volts. Okay, the total is 12.75. And you know 12.75 means n is equal to 4. Now only we have discussed this. So the answer for this is n is equal to 4. Now we are coming to question 38. Out of the following, which is not possible? That is asked. Which is not possible? Let us find out what kind of radiation is not possible in hydrogen. Okay, listen. See, we discussed this energy level diagram. You come here. This energy level diagram we have discussed. So, 13.6 to infinity means 13.6 is possible. This one, 13.6 is possible. Okay, then what is the difference between 13.6 and 3.4? The difference between these two is 10.2. That is possible. Okay, but 10.2 not given here. The difference between these two is 1.9. The difference between 3.4 and 1.5 is 1.9. That is possible here. So 13.6 is possible, 1.9 is possible. But 10.2 is possible, 11.1 is not possible. Let us check whether 0.65 is possible, because 0.65 is the difference between these two. When you subtract 1.51 and 0.85, the difference is 0.66. Therefore, that is also possible. So, which radiation is not possible is 11.1 electron volt is not possible. Now, we are straight away coming to question number 41. 41, the energy of the hydrogen atom in the ground state is minus 13.6. We know. What is the energy of the helium? That means, you know, the energy formula we have written here is Z square by N square. Therefore, what we have written here is for helium, we have made a table. So, for helium, N becomes, Z becomes 2. So, minus 13.6 into 4. Therefore, the question is, the first level, they are asking the energy of the He plus ion in the first excited state. First excited state means N is equal to 2 and the answer is minus 13.6. You understand? First state means minus 54.4. First excited state means N is equal to 2 minus 13.6. So, this is the correct answer. Okay, now I take you to question number 48. 48, what is given? The ionization energy of the electron in the hydrogen atom is 13.6. Ionization means from the ground level, you shift the electron to infinity level. For that, you have to give 13.6 electron volts so that this energy becomes 0. 0 means infinity level. The atoms are excited to higher energy levels to emit radiations of 6 wavelength. Maximum wavelength of emitted radiation corresponding to the transition is. Okay, find out. There are 6 wavelengths possible. That means, just now we have discussed, when N is equal to 4, there are 6 wavelengths possible. So here, what is the largest wavelength? That is the question. Maximum wavelength. I told you maximum wavelength means what we should do? Minimum energy. Maximum wavelength means minimum frequency. Minimum frequency means minimum energy. So in this is minus 13.6, minus 3.4. The gap is 10.2. This is very big. Here minus 1.51. Gap is 1.9. Here the gap is 0.85. The gap is 0.66. So minimum is this one, 4 to 3. That is the minimum wavelength. Because when we draw the energy level diagram, we have to draw it with proper gap. We have drawn it here with the proper gap of it. We have drawn it here. You know, this gap is very less. Here it is having more gap, more energy. Okay, so 4 to 3 is the transition which is having minimum energy. So that option is here, 4 to 3. Now where are we going? 51. See this, the ground state of hydrogen atom minus 13.6. When this electron goes to the excited state, what is the excitation energy? You know, it is 13.2. The excitation energy means the difference between this and this, that is 10.2 electron volt. Okay, we are coming to this page. What is this? The total energy of the electron in the ground state is minus 13.6. The kinetic energy, okay, in the first excited state. First excited means N is equal to 2. At N is equal to 2, how much will be kinetic? Minus 3.4. You know that. Come here. So you have the table here. When N is equal to 2, that is a first excited. What is the kinetic? Plus 3.4 electron volt. That is here. Very simple. Now, next question. Ionization potential of hydrogen atom is 13.6 volt it should be. There's a printing mistake. Volt. Ionization potential. Ionization energy means electron volt. Okay. Hydrogen atoms in the ground state are excited by monochromatic radiation 12.1. Okay. You come here. We have discussed this one. 12.1 comes where? It is 12.09. That is from 0 to 1 to third. 1 to third. That is 12.1. So 12 point. According to Bohr's theory, how many spectral lines are possible? You can tell me. We have discussed this. When N is equal to 3, 12.1, N is equal to 3. How many spectral lines possible? 3 to 2, 3 to 1, 2 to 1. 3 possible. So 3, that is the answer here. Now we are going to 64. Total energy of the electron in the excited state is minus 3.4. Total energy minus 3.4 means what? N is equal to 2. What is the kinetic energy in this state? Plus 3.4, that's all. Okay. If the total energy minus 3.4, kinetic energy plus 3.4. Okay. Then we are coming to the next one. The energy levels are given like this, and what is the formula? Okay. This I will have to little bit calculate and show you. I'll show you. See, energy level A, B, C. The values are given. This is smaller, this is bigger, this is very big. Okay. Make a diagram. This is A, this is B, this is C. A, B, C. Now what is given? Lambda 1, lambda 2, lambda. What is lambda 1? C to B, lambda 1. B to A, lambda 2. Lambda 3 is C to A. This is straight, that is lambda 3. What is the relationship? Okay, let us find out. Okay, this is lambda 3. This is energy level diagram. This is not wavelength. You cannot add this and say lambda 1 plus lambda 2 equal to lambda 3. Like that you should not say. This is wrong. You can say energy 1 plus energy 2 equal to energy 3. You can say this. You can say frequency 1 because energy is h nu 1. H nu 2, H nu 3. So what happens? Frequency 1, frequency 2 equal to frequency 3. Nu is what? C by lambda. Lambda 1, C by lambda 2, C by lambda 3. Velocity of light can be cancelled. So what you get is 1 by lambda 1 plus 1 by lambda 2 is equal to 1 by lambda 3. Take LCM. Lambda 2 plus lambda 1 by lambda 1 lambda 2 is equal to 1 by lambda 3. Therefore, what is lambda 3? Lambda 1 lambda 2 by lambda 1 plus lambda 2. So this answer, where is this? This answer is in option B. That's the correct answer. This question is asked 2 times, Some questions are getting repeated. Okay, fine. Now we come to next. Where is the question? We are searching this. Okay, question 88. The energy in hydrogen atom nth level is En, then nth orbit energy for helium is how much? Okay, hydrogen energy in the nth level is minus 13.6. We know this. For helium, how much it will be? It will be, general formula is Z square by N square into minus 13.6. So again you are in the first level only. But Z will be atomic number 4 times. Therefore, when you multiply by 4, this is 54.4, or you can say this is 4 times En. So 4 times En is the answer which is given here. Okay, now we are coming to question 92. Here what is asked? Maximum frequency. That means what? Maximum energy. Where is maximum energy? Some transitions are given. Emission. Emission means higher level to lower level. 2 to 1 is emission. 6 to 2 is emission. But this is absorption. Electron cannot go from 1 to 2 and then emit light. It is not possible. Only we have to give light so that it goes from 1 to 2. Okay. So option A or option B. Let us see this. Which is having more gap. 2 to 1 is 10.2. Whereas 6 to 2 is a very small gap. Even infinity to 2 itself 3.4 only. You understand? Infinity to 2 itself 3.4. But 2 to 1 is 10.2. Which is bigger? 10.2. Therefore you have to say 2 to 1. So don't look at the big number and get confused. So now we are going to the next question, 107. See this. The energy of the ground electronic state of hydrogen is minus 13.6. The energy in the first excited state. Very simple. First excited means N is equal to 2. The energy will be minus 3.4. The total energy minus 3.4. Okay. Now we are checking any other question. Yes, there is. The energy of the hydrogen atom, the ground state minus 13.6. The energy, the level corresponding to the quantum number N is equal to 2. Same question, minus 3.4. Now, question number 118. What is given? When the hydrogen atom is raised from ground state to excited state, what happens? To potential kinetic. Okay, come here. Come here. Now what you see? When you go from 1 to 2, what happens? That means kinetic energy decreases. You understand? Because from 13.6 it goes to 3.4. That means what? Kinetic energy decreases. Okay, then potential energy minus 27.2. It goes to minus 6.8, which is the bigger number. This one or this one? Minus 6.8 is bigger number. Potential energy increases. What happens to total energy? Minus 13.6, minus 3.4, which is bigger? Second one is bigger. The total energy increases. Okay, come here. Both kinetic potential increase. Wrong. Both kinetic potential decrease. Wrong. The potential decrease, kinetic increase. Wrong. Potential increases, kinetic decreases. This is right. Okay. Now we are going to 128. Go here. The ionization energy of hydrogen atom is 13.6. Following Bohr's theory, the energy corresponding to transition of 3 to 4. 3 to 4. What is the energy between 3 to 4? Okay. Come to the energy level diagram, or you can find it here also. 3 to 4. 3 and 4, the difference in energy 1.5, 1.85. Okay, look at this table also. 3 and 4. This is 13.6, 3.4, 1.51. 4 is 0.85. What is the gap between the two? 0.66. Okay, the answer is 0.66 is in the option D. Now we are coming to question 136. The ground state hydrogen atom 13.6, the energy needed to ionize hydrogen atom from the second excited state. Already hydrogen is in the second excited state. Okay, second excited, N is equal to 3. N is equal to 3 means minus 1.51. How much energy is required for ionization? You want plus 1.51. You understand? Okay, option A. Now I am coming to one last question here. The ionization energy of the hydrogen atom is 13.6. What is the ionization of a singly ionized helium? Okay, so hydrogen it is 13.6. For helium it is 54.4 because you have to multiply by 4. The answer is D. So I hope you understood all this. Okay, you have to, if you want, you watch it more than once to understand this. So my point of view is that in physics, if you want to get high score, choose the concept which is very, very important concept. Important in the sense, from which concept many questions are coming. From this concept we have seen 21 questions have come. This is a very small concept. So you choose those concepts, thoroughly prepare those concepts and work out the problems asked in the previous years based on that concept and make yourself thorough. So if I ask you more questions from energy level diagram, definitely you will be able to answer those questions. Thank you for watching.